Feedback link will be posted in
Minimum.
posted in
Minimum.
all present here. I thank God Almighty for
Minimum.
this beautiful session. Important reminder. An important reminder. Feedback link will be posted in YouTube chat box and description box at the end of the session. I repeat, feedback link will be posted in YouTube chat box and description box at the end of the session.
Minimum.
Please stay connected till the end. A very warm welcome to everyone who got connected to this technical webinar, Insights into Machine Learning. This technical webinar is organized by Department of Electronics and Communication Engineering, SCAD. SCAD College of Engineering and Technology is situated in southern part of Tamil Nadu, Cheranmahadevi, Tirunelveli. Department of ECE provides numerous ways for our students to get upgraded to the new technology through online webinar and expert lecture and training. I'm highly delighted to introduce a well-renowned scholar and our chief guest, Dr.S.Sankar Ganesh, Assistant Professor, Department of Communication Engineering, Vellore Institute of Technology, Vellore. He has teaching experience for about 18 years. He published his papers in 16 international journals and 3 national journals. He is highly specialized in machine learning, machine vision, pattern recognition, digital signal and image processing. His chapter was published in the Handbook of Research on Fuzzy and Rough Set Theory in Organizational Decision Making. He completed his doctorate degree in the field of machine learning recently. He completed many consultancy projects. He is also a member of professional societies like IEEE, ISTE. He conducted many national workshops. Now I hand over the session to Dr. Sankar Ganesh. Please, sir.
Good morning, everyone. So, I'm Shankar Ganesh. I'm from Vellore Institute of Technology. First of all, I would like to thank the SCAD College management and faculty members who have organized this technical webinar. So, I'm just going to brief about. So, even though the title of this technical webinar is Insights into Machine Learning, so I'm going to brief about the machine learning, irrespective of algorithm. So whatever may be the machine learning algorithm we are going to discuss, in that there are some common steps and important steps which decides the performance of each machine learning algorithm. So that we are going to discuss. So machine learning, it is one of the fastest growing fields. It is not only that the data is continuously and enormously getting bigger, but also the theoretical knowledge of about that this data process, how this data is turned into useful information and knowledge, that is also growing leaps and bounds. So machine learning is one such kind of algorithm techniques in all the fields in our day-to-day life, be it from science, astronomy, and into biology. Everyday life, there is a need for digital technology. Even one such example is this technical webinar. And then in this pandemic situation, we are meeting so often through virtual mode. So all this digital technology with respect to data, it infiltrates and becomes one of the possible aspect of our day-to-day life. So it is infiltrating onto our digital footprint, and this digital footprint deepens and deepens. So where we are having enormous dormant passive data, So smart people like the machine learning engineer, those who know about the machine learning, the importance of the data, know the way to convert this enormous data into useful product where we can use in day-to-day life. And machine learning plays larger and larger role in that. This is the age of big data. So in ancient times, we had a computer center where they are entitled to use the system. From there, we have to get the data, gather the data. But nowadays, we are having the system. So we can collect the data, we can collect the data, we can gather the data of our own. So right from sensor to whatever the hardware which we can use in our day-to-day life, anything which is restricted to our day-to-day life, we can extract so much amount of data. And and still we have the belief that from this seemingly complex and voluminous data, we can easily get the information by a simple mathematical model. So that model, we will call it as machine learning. So getting into this, so these are the few common definitions of machine learning. So this application of machine learning, if it is applied to the larger database, then it is called as data mining. So the machine learning, it's not a standalone, it's an integrated approach. The machine learning is getting an hand-to-hand help from so many other auxiliary field, that is like statistics, and then data analytics, data engineering, expert system, and then signal processing, image processing. So all this combinedly, we want to develop a simple model where we can, that model is replaced by, the man will be replaced by that model, and whatever we do, the machine or computer performs. So as I said earlier, so this application, the machine learning application, if it is employed, it is applied to a larger database, it is called as data mining. Not only the machine learning is restricted to the data mining, it is also a part of artificial intelligence. So hope you get what is the difference between machine learning and artificial intelligence. So machine learning is a subset of artificial intelligence. With the machine learning, we are making the artificial intelligent systems. So when I am talking about the system, it processes the input. So it is acting as a node. So whatever the input we are getting, so it will process as per our instruction. So this system has to be continuously adaptive. It shouldn't be robust. It should be adaptive to the environment. It should accustom to the changes in the environment. It should flexible to the input. It should be fault tolerant. Such system, and which has the important capability of learning, is called as machine learning. So if a machine, with respect to whatever the properties which I have mentioned earlier, the important property is its ability to learn. So the key word is the learn. So the learning, when the learning takes place is, if we are robust, it's very difficult. So we should be adaptive to the changes with respect to environment, and we should be adaptive to the changes to the newer inputs we are getting before respect to the trained input. So if any system which has this ability of adaptiveness, then we can employ this system in so many problems, and we can find a solution for all possible ways. So machine learning is one such kind. It's a system which has the ability to learn. So it is employed in speech processing, vision, and then robotics and many recognition problems. We are employing this machine learning algorithms. Okay, so if we could see this common definition, so the most common part, the most common word in most of the definition, it has learning and algorithm. So this algorithm is a step-by-step procedure, how the input, from the input, how it is processed, in what way the inputs are processed, how we are making the decision, or how we are getting the output. So that is an algorithm. So this set of algorithm varies for different machine learning techniques. Oh, so this is the common notion or common definition you can come across in more common way. Oh, so what is machine learning? Where we are going? How is it possible? So that I can add. So I can quote you a simple example. So if we are having the family photograph, so even after 5 years, 10 years, or 20 years, we can recognize the family member. So that is the simple logic. It is already pre-built with respect to our nervous system. So the family members are stored in our brain, and there we are retrieving the information from the brain. So how we are identifying, we don't know. But the same, if we want to teach it to the system, where we can have thousands and thousands of data sets, and each data set is having enormous, humongous data, and then larger data sets combination. So if we are having so many images, how we are retrieving, how we are recognizing the person. So that is very important. So both we are having an analogous, both are analogous. So we can take the analogy from our nervous system, our brain, how we remember the family members, and the same we can feed it to the system. Like for every family member or every person, apart from the name and apart from the face, we are having some structures, some symmetric patterns, so that we will train it to the system, and this is called as pattern recognition. So with the pattern we can identify the different persons. So whatever we do, whatever from our intelligence, how we are doing a particular operation, the same if we are converting to mathematical models, and then that mathematical model is programmed to a complete set of algorithm. So that we will call it as machine learning algorithms. So these are some of the words. So you could see, so machine learning can predict, forecast. So with respect to time series data, we can predict the price of stock. We can predict the number of infection. We can forecast with respect to rainfall. We can forecast the quality of air. So that this machine learning can predict and forecast. And then some keyword which is called as training. So this is just a type of training. So before getting into the test field, we will be trained and then we will be tested. So the training is very important part. So often the machine learning is confused with artificial intelligence, deep learning, neural networks, and big data. So as I mentioned earlier, machine learning is a subset of artificial intelligence, and deep learning is another subset of machine learning, where we can take multi-layered input than in machine learning. And then neural network, it is also a type of machine learning, and where we can able to find the output, or we can able to decide the particular classification or identification by weights change. If the number of input is more and multi-dimensional, so the entire input data has to be collated, gathered, pre-processed. So the technology or the technique involved around that enormous data, or huge data, is called as big data. So we need not to worry. So whatever the machine learning algorithm, so our target is 100% accuracy. But most of the application, with respect to application, even if we could achieve with 80%, it's well and good. So the machine learning in big data, data science, and data engineering, so all with respect to the particular input, and then we can have a common where there is ML programming. So Python is the simplest language, open source language, where we can code most of the machine learning algorithm, and it is compatible too. So with respect with this introduction, and before I mentioned, when a machine learning or a system is said to be finding the solution for most of the all possible problem is the type of learning. So hope you know the difference between training and learning. So in learning, there will be more intelligence than in training. So there are different types of learning. with respect to the type of learning, that is supervised, unsupervised, and reinforcement. So these are the three major classification. Most of the learning algorithm can be classified: supervised, unsupervised, and reinforcement. So supervised learning, and before getting into that, we cannot say that supervised is better than unsupervised, or unsupervised is better than reinforcement. The inter-comparison, we cannot tell one is inferior, another one is superior. So depending on the application and what type of input we are going to take, so that will be your, that depends on the type of learning system we are employing. So if supervised, if you know the exact number of input, then the supervised may be the better one. So I can quote you a simple example I have given. So my task is to differentiate the apple and orange. Hope there is no much difference between apple and orange. So how could I classify, or how could I differentiate apple and orange? So I can take the input as size almost same. So then I can take this texture, it will be different. I can take the weight, so it is different. Then I can smell the order, we can have the different way. So these are the different inputs. So for any machine learning we are taking into account is playing a crucial role. So one notion we want to remember is we want to choose the input which is having the impact on our output or the decision making. So all the inputs we want to take it. Suppose if I want to implement machine learning for just an implementation of a gate, 2 input gate. So what is the maximum combination I can train the model? 4. So if it is 2 input, I can train it with the maximum of 4 input. So that is the task we want to take it. Yes, similarly, so all possible inputs we want to take it. So hope you, this is the same thing we will be getting for the different types of learning: supervised, unsupervised, and reinforced. So getting into the supervised learning, where we can, if we know the number of input and if we know the number of input combination, and for each and every input combination corresponding individual output, if we are having, or if you know, then it comes under supervised. So that is called as labeled. Already the input data are labeled, and with the input data, so we know what are all the input. For each input, what is the corresponding output, we can know. So that is that type of application where we need, in that application we can employ supervised learning. Unsupervised learning, we know the input, but they are all unlabeled. We cannot classify. We don't know the prior information of the output. Then it comes under unsupervised learnings, where the data are unlabeled data. So if you want to choose the best fit or best solution, so we cannot make it with a single choice. So we need some group of choice which is considered to be the best for a particular application. So if we are using that kind of feedback, then it is called as reinforcement learning. So for an input, if we find that this is output is the best, then we will take that output also into the account for training the next set of inputs. So that is called as reinforcement learning. So these are the 3 major types of learning in which most of the machine learning algorithm can be classified. Other than that, so we can have a learning with respect to feature vector, and with respect to logical expression, we can have the different types of learning. And then the use of knowledge, empirical. So with the prior experience we can do, or it may be analytical. So already proven result or already proven hypothesis theorems, with which if we could develop a learning system, then it is called as analytical based learning system. So these are the 7 important steps in any machine learning, be it some 20 or 25 types of machine learning algorithm. On all the machine learning algorithm, these are the 7 essential steps. So the first is gathering data, that is data collection, or we are collecting the data. So that is very important step in any machine learning algorithm. So how it is important. So we want to find the output, or we want to decide, or we want to predict. Suppose, for example, if I want to predict the quality of air of a particular city. So how can I predict the quality of air? Then I need to gather the information of all the pollutants, all the particulate matter of that city, which is contributing or which is responsible for the pollution of particular city. So if I am missing any one of the sensor data or any one of the pollutant, then I cannot predict the model. So that is the main step in any machine learning algorithm. Otherwise, I will put it in the simpler way. So you want to prepare for a paper. You want to give an examination for a paper. You want to prepare for that subject. So we need to collect all possible information, be it whether we need some standard tables, be it whether we need any data book, be it whether we need any prior programming skill. So everything we will collect prior before taking into that course. So that is very, very important. So this is called as raw data. So we have not, it's not structured. So we have taken it from all possible inputs, we have collected the data. Then the second step, it is called as preparing the data to the machine learning algorithm, or preparing the data to fit the model, or preparing the data so that it can be processed by the model. So that is also called as data cleaning, pre-processing. So here the raw data will be converted into the structured data. So what we will do is, if there is any outliers, we will remove that outliers. And if there is any unfilled data, so if I need 5 input variables for predicting one output variable, in few days or in few cases I am having the reading for only 3 variables, means then I can remove that data. So that is called as data cleaning, pre-processing. And one more pre-processing we will do it in the case of neural network is where all the data, be it with so many inputs we want to take it, all should be normalized to 0 to 1. So that is also we will call it as pre-processing. That is max min pre-processing or max average pre-processing. So these two steps are the essential steps with respect to input, that is collection of data, and then pre-processing the data with respect to the algorithm. Then we are going to choose the model. So all the machine learning algorithm which I am going to list it out and then briefly discuss in the upcoming slides. I am going to choose a model. If it is supervised, then I can choose a different set. If it is unsupervised, I can choose a different set of machine learning algorithm. And then I have chosen as per the application, as per the input which we gathered, and what is the impact of those input on decision making. Accordingly, we will choose the model. And then the last 4 parts. So that part is the highlight which I have quoted before. That is ability to learn, ability to change with respect to environment. That is adaptiveness. So that comes these 4 steps: training, evaluation of a model, then parameter tuning with respect to the previous performance measure, and the last one, what is the output, and that we will take it out of the particular model. So training, and that is called as splitting of data sets. That is the raw data, pre-processed the raw data, and which is suitable for our model, so that I want to train it. So I'll just give a simple example. So I'm having some 6 binary inputs, or 6 binary inputs. So what is the maximum combination of input I can make? It is 2 power 6. So I want to train the model with all possible input combinations. So the entire 128 input combination to be trained with the model, or to be trained with the model, then only the complete training is done. So if I am not doing the all possible input combination, So whichever the combination which I have not trained, whichever the combination I have missed, if that input comes in the real time, the model cannot find or cannot decide the output for those input which I have not trained. So all possible inputs we want to train. Here also I am making a point, it is not with respect to number. So the number of input combination we will determine, that is which are all the input combination which is having an impact on your decision making output, that all the input should be trained. And then so I have trained the model. So if a course having some 6 units or 6 modules, so the lecturer or faculty should give training to all the 6 modules or whatever the modules in the particular course or paper. If you miss the training in a particular course, if you find across the question in the examination paper with respect to the particular unit which you have not trained, so remember the situation. So the same applicable to model also. So whichever the input combination which is having an impact on decision making, all the input combination should be sorted out and it should be trained with the model. So that is the first and foremost. Then second, so we have given the training and the model is ready. So if I have trained with some 128 input combination, so whichever the combination of that 128 is coming, easily we can have the decision making. So that is, the model is trained and then we are testing the model. So after the testing, it's like the marks you are getting after the examination. Then we will evaluate whether the model is good. So that is called as evaluation performance measure. And then so with what are the performance measure? It will be depending on number of epochs and what is the stopping condition we have given. And if it is unsupervised, then we will have the cross function. So I'll just throw a light on epochs. So as I said earlier, 6 inputs I am having binary. So if I have trained with all 128 input, that is the meaning of one epoch. So the epoch is that if I complete one epoch, meaning that all possible input I have trained with which I have trained the model. So if it is iteration, it's just like for loop. One operation we are doing it for n times. Here all the input we should do, so that complete one epoch. So likewise, still to achieve the target. So if I am going to keep on increasing the epoch, so we are not going to achieve the target. So the error cannot be 0. Ideal condition, the error will be 0. So the epoch will be infinite. So we need some stopping condition on which there is a convergence testing is there, and we need some stopping conditions. How we are stopping the epoch? Suppose, for example, in this machine learning algorithm, I had did it for 50 epochs, then I have achieved the optimized result. Then why I am stopping it at 50th epoch? So that is called a stopping condition. So we can do it with the reduction in the cost function as the epoch increases. So the error cannot be 0. We will achieve error at 0 only at infinite. Okay, so I have evaluated the model. So now I want to increase the performance of the model. So once again, what I will do, so as I said earlier, it is adaptive. So it's fault tolerant. So I will tune the parameter with respect to the performance measure. I will do it. Then once again I will check the output. So we know the what is the output we want to get if it is the case of time series forecasting, and then what is the after testing what we have achieved. So that is also we need. So we know. So with respect to these, we will have the different error measurement, and with which we will once again go back to the first. We will change the input as per our requirement, as per the target achievement. We will do it. So this is repeated. So be it any machine learning algorithm. So these are the 7 important steps. So here all the 1, 2 is common for all. 4, 5, 6, 7 it vary with respect to algorithm, but the concept is same. And the third we can fit into any model. So this is the basic learning steps in the machine learning. So whenever we are saying the ML model metrics, So the factors determining how well the machine learning algorithm perform are categorized, are determined by two important factors. One is the training error should be small, and the second is the gap between the training error and testing error should be very, very low. So if these two are achieved, then we can say that the model is performing the best, better way or best among the set of algorithms. So we need low training error, and then the gap between training and testing will be very low. So these are the two things. So achieving these two things, it's really challenging. So this leads to two other challenges, which is called as underfitting and overfitting. So these concepts are very, very important in the machine learning algorithm. So where underfitting is the model not able to produce the low error during the training set, or the lower training error is not achieved by a model, then we can tell that the model is facing underfitting problem. Overfitting is the otherwise. So if there is a large gap between the training and testing error, then we will call it as overfitting. So if these two are achieved, then we will call it as statistical fit. So the statistical fit or exact fit, it is between underfitting and overfitting. So I can just quote with a simple example. Suppose if we want to stitch a cloth. So what we will go to is we will go to the tailor shop. So we will give the measurement, accordingly the tailor will stitch. So while taking the measurement itself, if he is not taking the properly, that is analogous to the training. So training error is there. Then after stitching, it is not fitting to ourselves. So that is called as underfitting. And then overfitting, the same tailor while taking the measurement. So he is approximating the training. So he is giving the measurement for, he is taking the measurement for all the parts which we no need for that stitching. So he keep on training for all possible inputs, and then if he is stitching means it will overfit for us. So our cloth will not suit for us. In both the cases, there is a problem. So while training, if we are not concentrating, it will lead to underfitting. So if we are not concentrating on a training, that will have the adverse effect while testing. Then the gap between training and testing will be more. So there we will have overfitting. So overfitting, underfitting problem has to be eradicated, and we need a fix between underfitting and overfitting. That is called as the statistical fit. So how we are getting those statistical fit? So this is a few examples. So you could see what is the problem of underfitting. So where I need, this is a two classes. So this is the decision boundary, and you see above the decision boundary, I am having some 4 inputs, which are these 3 circles. It should be classified as circle because the decision boundary is here. We will classify it as cross. This is called as underfitting, and this is overfitting. So where we are having more training, and then the training error will lead to the testing error, and then we are having, so this is more complex and this is more simple. We need a fit between the simplest and the complex one. So that is called as appropriate fitting. So reduce the underfitting, we have to increase the model complexity. So that is we need some exact measurement for stitching the cloth, and then not only the number of input, we should increase the number of inputs, and then we should remove the noise from the data, and then we can have to give more training to reduce the underfitting. So these are the techniques where we can reduce the underfitting. To reduce the overfitting, we have to increase the training data, and then the model should be simple. It should not be complex, and then we need not to train it for a long time. So the early stopping during the training phases advantages. So these are the techniques with which we can reduce the underfit and overfit, and we can easily achieve the statistical fit for any machine learning algorithm. So how we are going to achieve this statistical fit? So too confusing the term, and the two terms with which our model metrics are finalized, and are generalization and regularization. So the most central challenge, be it any algorithm, the first thing is the model should perform well for all possible input, not only to the specific input which we trained. So even the input which we have not trained, which is similar to the input we have trained, so the model should able to perform with respect to previous unobserved input or untrained input. So that is called as generalization. So what is the meaning is, we have a general model for all possible input, whether we trained or we have not observed before. That is called as generalization. So generalization or the testing error should be low in order to reduce the overfitting and underfitting problem. So in any machine learning algorithm, so the performance of test set examples are collected separately from the training set, meaning it, so we want to distinguish the test set completely from the training set. Otherwise, what is the meaning is, whatever the training we have asked, the same test if we are taking means, it is like giving the answer, whatever the problems or whatever the question solved in the class, same if you are repeating in the exam. It is there is no way we are testing the model or the individual. So the same example we can take it. So the test sets should be completely separated from the training set. And so the most toughest part, and where we require more mathematical concept, is regularization. There is no specific regularization method, and we can tell that this is the best method to regularize the generalization error. So as per our application, so this regularization methods will keep on varying. So that is called as the regularization. These two terms are very important to avoid underfitting and overfitting. So if we take care of this learning model, which is one are better compared to other learning. So as I told, the sixth step is hyperparameter and validation set. So we are having, in many machine learning algorithm, we are having some parameters. So each parameters will have the different behavior of the learning algorithm, and these parameters will define the behavior of the learning algorithm with respect to particular input set. If we vary that parameter, the behavior of the learning algorithm will change with respect to the input. So these settings are called as hyperparameters. So usually the most common way of taking is, among the data set, 80% of the data set we will take it for training, and remaining 20% we will use it for testing. It is called as, in the case, validation. So the validation set is used to train the hyperparameter. Once it is trained, then we will have the training error, that is validation set error, will estimate the generalization error. So if we know the generalization error, we know that whether we are facing underfitting or overfitting. With respect to the training error, we can once again tune the parameter to reduce the training error to avoid the underfitting. So after optimizing all the hyperparameter, because certain parameter we cannot restrict. So if it is alpha is the learning parameter, it takes the value from 0 to 1. So we cannot reduce beyond 0, we cannot increase more than 1. So certain restriction is there. So that is the optimized value, where we are having a trade-off, or we have achieved the convergence. So that is called as optimized. So once the hyperparameter optimization is complete, the generalization error once again estimated, and if we are satisfied or within this generalization error is within the range, then we can test the 20% of the data. So if we have given more importance or more analysis, if you have done more analysis on the training side, we will reduce the generalization error, which lead to easier regularization, and the model will be the better one. So there are other way of validating the set. So if I am having 100 data, 80 data I will use it for training, and the last 20 data I will use it for testing. So if what would have happened, instead of last 20, if I have taken first 20 as the testing and remaining 21 to 100 as the training. So that way we have to check it for the different set to play around the 100 data. That is called as cross validation. So the one important cross validation is k-fold cross validation, where we will divide the data set into k non-overlapping subset. The k will be any integer we are going to take. So that sets we will be keep on taking, and we will be training and testing with the non-overlapping subset. So that is called as validation, the important step in any model metrics. So these are the machine learning algorithm group. I'm not telling that these are the machine learning algorithms, and under these heading we are having some 4 or 5 machine learning algorithm under each group. So machine learning, so there are some deep learning algorithms, there are ensemble algorithm, there are some learning methods under neural networks, there are different ways to regularize the testing error, rule-based, regression, Bayesian, decision tree, then dimensionality reduction, instant-based, and clustering. So these are the group. So the machine learning is a tree, and these are all the branches. And we are having so many sub-branches also. So that we will discuss one by one. So first is Bayesian learning. So this is probabilistic learning, which we know some information prior. So this is the Bayes rule, and we are having, if we know the information or if we have made some assessment, it is called as prior, and with the prior, if we predict or if we find the outcome, that is called as posterior. So if we use only the prior and then posteriori with different outcomes, we can take it. So this is the Bayes rule. This is called as the conditional probability, where the probability of B is known. We want to find what is the probability of A. So how we can calculate is, we need some information about the A. That is probability of A. If B probability of A happened, what is the probability of A into individual probability of A divided by the total probability of B. So we need some information or some assumption to predict the outcome posteriorly. So that is called as the Bayesian learning. So with this likelihood, if we get the estimate point for all the parameter, then it is called as maximum likelihood estimation. If the prior, the assumption which we have taken earlier, that is alone taken into the account, then it is called as maximum posteriori estimation. So MLE and MLP are same if the prior is uniform. So if we know the input, or if we know the assumptions, a few assumptions before, with which if we could assess the outcome, then it is called as the MLE. And if all the prior is taken, then we will be taking it as the posteriori value. And these are the different learning algorithms: nail-based, and then average one independence estimators, Bayesian belief network. So I'm just listing out the algorithm. So for each algorithm, what is the important steps which is needed? So that I have already discussed. So for this also, we should be taking care of input, pre-processing. Then we can choose any Bayesian learning algorithm, and then we can evaluate the model. We can hyper tune, or we can tune the parameters, and then once again we will check the output. We will check the accuracy of the output or efficiency. Then we will keep on moving it. So the second branch is called as the decision tree. So this is an algorithmic approach where the data set is splitted depending on the condition. So suppose, for example, I want to decide whether I want to go to the hotel or not. So if I am free, I will go to the hotel. If I am not free, I will not go to the hotel. So this is one. It's just like binary, yes or no. So if I want, how the machine learning can solve this problem is, if I go to the hotel, whether I want to check the table is free or not. If that is one branch. If the table is free, whether I will get the my favorite dish or not. If I get the favorite dish, whether it will be tasty or not. If I get the tasty food, what is the amount I want to pay? Even if it is high also, what is the hospitality ambient environment I can classify. Likewise, the other side also there. So I don't want to wait. I don't have the dish. So you could see. So the decision is whether I want to go to the hotel or not. So all the subdivision we have taken till if we get what we want, what are the different steps. So what is the meaning is, so if we want to propose a model or if we want to market a product, so if we are taking the decision tree, we will analyze in all the nooks and corners of all possible environment or condition which is having the impact on customer whether to buy the product or not. So that ways it will be helpful for the decision tree. So this type of application, maximum they will give the answer should be yes or no. But that arriving that yes, we would have taken some 10 steps or 20 steps before analysis. So that is called as the classification. That is called as the decision tree. So here we will have the two types of keywords, that is output variable, regression and classification. So the regression is numerical, where we are having the continuous. Classification is categorical. It is linguistic, yes or no. If it is yes, 1. If it is no, 0. So that is where we will have the decision tree. So some few the decision tree algorithms are there. So the key concept is the decision tree, why we need it, and these are the different decision tree algorithms. And the next branch is dimensionality reduction. So I'm just giving you an example. So there is a temple where we are having an undial. So everyone will be giving their offering in the undial. So I want to analyze the total amount. I want to find the total amount. So it is easier. So what I will do? So I will take all the money, all coin, I will add it, I will find it. Suppose I want to analyze more. That is how many 5 rupee coin, 5 rupee note, or I want to check it with the denomination means, then I want to find the individual variables. So instead of 100 variables, if I am splitting that 100 into different subset, then that is called as dimensionality reduction. So in the undial, if I want to find how many 5 rupee coins are there, already I have separated, so that I will get it. So if I have not separated, what would happen is, whenever I need what is the amount of number of 5 rupee coins or 10 rupee note, once again I have to count it from the beginning, the entire amount in the undial. So that is what we'll call it as dimensionality reduction. So the entire data set, the input random variables, we will be setting into principal variables. So this principal variables will have the effect on your decision making or output. That is called as dimensionality reduction. In other way, we can call it as feature selection and feature extraction. So depending on the input, these two terms will vary, feature selection and feature extraction. So this is a 3-dimensional picture, and how it is split into two 1-dimensional split we are having. So if I need what is the variation of x with respect to y, I cannot take it from 3-dimensional. I can take it if I reduce the 3-dimensional to 2 1-dimensional. Similarly, how the z varies with respect to y, I need a 1D. So this is called as dimensionality reduction. How we are achieving the principal variables from the set of raw data or random variables, the random input variables, we are having these many dimensionality reduction. So it is mixed principal component analysis, the most commonly used. Then PLSR, Shaman mapping, MDS, projection pursuit, PCR, then partial least square discriminant analysis. Discriminant analysis, 4 types: linear, mixed, quadratic, flexible, recursive, and then linear descriptive analysis. So all the key aspect is how we are determining the principal variable from the input random variables. And the next branch is the instance based. So instance basis, it's like memory. So we have stored some data in the memory, and we want to retrieve the data which is stored only in the memory. So that is called as instant based. So whenever we are getting the new instance, we will immediately refer the memory, and from the previous instances we will analyze what would be the output pattern. We will map it to the new instances. So this is local approximation than the global one. Here the training will be very easier just to store the instances, but the testing will be very difficult. Even if you want to predict, or we want to check the instance of one occurrence, new occurrence, if there is a n data stored, so I need to compare for a new instance of 1. Then 1 has to be compared with the n number of data. So the testing is expensive. So depending on the application where we need, that is where decision making is depending on the neighbors, where the decision making is depending on the closer circle, where the decision making is depending on the peers, neighboring peers. So there we will use the instant based. So the most commonly instant based algorithm is k nearest neighbor or KNN classification, then LVQ, learning vector quantization, and self-organizing map, SOM, locally weighted learning. So all the 4 will be coming under unsupervised learning, where we are doing clustering, classification. So that we will be having it the instant based algorithm. So as I mentioned earlier, so both it's more or less same. Clustering, where we are going to group the input, not reduce the data point, we are going to group it prior. So the classification of each data point or each input will be decided to classified to particular group. So that with that information we want to do it. Suppose for example, if I am having a food items which comprises fruits and vegetables, so the first classification I want to make is which is fruit, which is vegetable. Then another classification I want to make it, if it is fruit, what type of fruit, if it is vegetable, what type of vegetable. So that is called as hierarchical clustering. Initially we will assume all the data point to a one cluster, that is food item, edible item. Then the edible item is classified into 2 nearest cluster, fruits, vegetable, that is called as nearest cluster. Then the fruits will be divided into sweet, sour one. Vegetable, whether it is edible or it is under the ground or above the ground. Likewise, I will keep on classify the cluster till the single cluster is there. So particularly if I am having apple, then apple belongs to fruit. In that fruit, it belongs to sweet. If it is sweet, whether it is round shaped or the lengthier one. So likewise, I will do it. Still, apple is classified into single cluster where the further clustering is not possible. That is called as the clustering. So these are the different types of clustering algorithm. And the most important and commonly used is k-means clustering. So similarly with respect to IFM algorithms, so these are the few machine learning algorithms which consider the rule system algorithms. And as I mentioned earlier, we are having the regularization. We are having the regularization techniques which will determine the model metrics. So these are the different types of regularization techniques more commonly used. And then regression model. This model is used to build the relationship between input and output, where the input will be the dependent variable, output input variable, dependent variables, and the independent variables will be decided with respect to the application. So where the independent variable will be the input variables and the dependent variable will be your output. So what is the combination of input variables which determine the particular output? That is called as regression. So if it is with respect to 1-to-1, it is called as linear regression. If it is with many input variable with respect to one dependent variable, then it is called as multilinear regression. So similarly, the regression model we are having the logistic regression, where we don't have any numerical value. We will go for the logistic expression and or R. So that is called as logistic expression. And these are the common regression algorithm: linear, logistic, then OLSR, Mars, and locally estimated scatter plot. So once again, I'm repeating all the machine learning algorithm I have repeated. So whatever may be the machine learning algorithm, the complete concept, so which we have taken earlier, that is all the 7 steps will be repeated for the entire machine learning algorithm. Then apart from that, for each branch algorithm, what is the essential constituent of that machine learning algorithm, I have just briefed out. And this will vary with respect to each and every algorithm. And then we want to improve the more classification accuracy, we will do the ensembling. So the ensembling will be the combination of different composite model, and which is the mix of different classifier group, that is called as ensembling. So we are having the different types of ensembling, that is random forest, boosting, bagging, ADA boost, stacking, then gradient boosted regression tree, gradient boosting machines. So this ensemble technique, mainly we will be taking it with respect to hybrid learning. So if there is a combination of suppose for example, I want to do a neural network algorithm and a regression. So the combination I can do. So what I have to do is, I have to ensemble neural network algorithm and the regression. So this mainly we use for hybrid learning. So that ensemble techniques, in that hybrid learning, how I am going to take the base classifier as well as the group classifier, we are having these 7 different methods. And then the most commonly used algorithm, that is called as neural network, and we will take our analogous, or we will take the inference with our nervous system. So how our nervous system respond to our stimulus, the same will take it from input to output. So here a combination of input are assigned with weights, and the weights are adjusted with respect to different learning law, and we will achieve at the new weight, and with the new weight we will take the decision. So the general weight updation formula is W nu equal to old weight plus delta W, where delta W is change in weight. So different algorithm will take the different way of finding the delta W. So if it is if the delta W is varied with respect to error, then it is called as back propagation or error propagation. If the delta W is taken with respect to mean square error, then we will go for Adeline type of learning, that is adaptive linear neuron type of learning. So likewise, the different learning method will have the different way in updating the weight. How the delta W is changed with respect to different learning algorithm will have the different learning methods. So few important learning methods are perceptron, that is multilinear perceptron MLP, backpropagation network RBFN. Then competitive learning, we are having SOM, that is supervised SOM. We are having LVQ, learning vector quantization, that is self-organizing map, LVQ, learning vector quantization. Then we are having counter propagation network, CPN. Then adaptive resonance theory, all are coming under competitive, and these are all unsupervised learning. And there are few supervised learning in neural network, that is perceptron, backpropagation network, RBFN will be coming under supervised learning. And the last, the branch is deep learning. It is a subfield of ML algorithm, which is inspired by ANN. So ML is subset of AI, DL is subset of ML. So instead, if I am taking the one-dimensional input, if I am taking the multi-dimensional input, how I am going to determine the multi-dimensional input, that will be called as the deep learning algorithm. So it creates the knowledge from multiple layers of information processing. So instead of taking the one-dimensional with respect to one input, if I am taking the multi-dimensional, suppose the machine learning algorithm which I have used is able to classify only the cats in the particular image, then another machine learning algorithm will identify only the dog. So if I combine these two, then more depth analysis if I am doing, and then it is called as deep learning. So these are all the 4 important deep learning algorithm: convolutional neural network, deep belief neural network, and stacked auto encode. Okay, so I will just brief out what we have discussed in this 60 minutes. So why we want to use the machine learning algorithm, and what is the essential property of the machine learning algorithm, what are the important steps, and how those each steps determines the performance of our model, that that we discussed. And we are having some 8 to 9 branches of machine learning algorithm. Under each branch we are having some 4 or 5, in some branch we are having 6. So all the available till now, so the maximum machine learning algorithm I have briefed, and then in each algorithm what we will do, so that I have explained. So if you know the fundamental concept of the machine learning as a whole, then we can easily adapt to what we have done. Suppose in deep learning algorithm, we should concentrate more on the input, whether we need the deep learning need for that input. If we could solve with simple ML, we can easily do it. If it is a classification problem of yes or no, we need not go for deep learning. We can directly do the other classification method. So likewise, depending on your application, will determine your machine learning algorithm, and the metrics of the machine learning algorithm will be decided by the metrics which I have told, that we are having underfitting or overfitting, and that can be once again concentrated, and if we concentrate more on training and testing, it will be go. So it's like a loop. So still, if we are finding problem with accuracy, we will fine tune the parameter, and each parameter there is a restriction, that is called the 6th step, parameter tuning. So with which we can do it. So that is the complete crust thing I can do. So lot of YouTube lectures are there, lot of digital online Coursera's are there, lot of books are there, because if you could see, if you put machine learning algorithms in the Google, you could see the lot. So the fundamental concepts are the very important backbone for this machine learning algorithm, which I couldn't touch with respect to this time frame, is the mathematics beyond this. So if you are comfortable or if you are good at mathematics, then all the algorithm we can easily do it. Suppose I told about the fitting, then we should know the gradient algorithm. So how the input curve is fitting with the output value, how we can reduce the testing value. It is not just like as simple as that. We can easily reduce the training error. It's lot of mathematics are there. So if you are interested, kindly put more effort and concentrate more on mathematics, then you can come. So there are a lot of platforms where we can have you can get the code for machine learning algorithm. So many case studies for each machine learning algorithm, but very few would have touched the mathematics beyond this machine learning algorithm.
We can quickly move on to the. Thank you, sir. Sir, we'll quickly move on to the question and answer session. I have forwarded few questions to your contact number. Can you check it, sir?
Yeah. So few questions are there. I will try to answer the most of the case. On which basis we choose data for training and testing data? So if you know your input, and with respect to input, what is your output, we want to decide. Depending on that, we are having the training and testing data. So the training and testing data from the same group. So only the numbers is varying. It's not that we trained with one input, we will test it with other people, other set of input. So the numbers is matter. So there is a single group, we want to decide the training and testing data. So but the testing data should be completely separated from the training data. Otherwise, what is the problem? I told the generalization, more training error will be there. So in Python, by using libraries, we can easily split train set. Yes, of course, you can easily split the train set. So it is not decided on the number. There is not the golden rule. It has to be 80-20. So usually, if it is in the MATLAB, we have to manually separate. So in Python, as in the case of open source platform, more libraries will be there. You can make use of it. So the suggestion what I want to make is you can have the analysis. You try it with 90-10, 90 for training, 10 for testing, then 80-20, 70-30, 60-40, 50-50. So because already the libraries are there, so you do this analysis and which part and which splitting is having the lesser error, that you can fix it for your purpose. For machine learning, implementation of which language can be preferred, R or Python, it's up to you. So we cannot say that R is better or Python is better. It is up to your skill and your interest, what is the experience you are having for each and everything. But most of them, they are using the Python because it's open source where we can get lot of help. How to split train and testing data, that I am told it is 80-20. Will efficiency problem occur if you use 50-50? Surely it will be having the lesser efficiency, because we are giving training and we are testing with equal amount. It's like out of 5 units you want to teach for learn for the particular course. If I teach 2 units and if I test it for the remaining 3 units, what will happen? The same will happen to your model. Can we change 80-20 to any other number, say 60-40, as you can do, unless you fix the norm for the cap for the efficiency or the different performance measure like mean square error and mean absolute percentage error, correlation coefficient, correlation. Depending on that, you can split it. Why we take 80% train and 20%? Most of them are taking. So with respect to what I did it for my data set is I did it for, as I mentioned earlier, it's 60-40, 70-30, 80-20, 90-10. Among that, the 90-20 will be there. So if you are reducing to 90-10, or if you take 95-5, there is no meaning how the model will behave for the test. So more the testing we are checking, more generalization we will have. How optimization implemented in machine learning? That's very good question. So that is also another branch we are having the optimization. So all the machine learning we need optimization. So the one such thing I told us, if we are having the batch gradient, the gradient is the simplest way of doing the optimization. So where we will do any one of the machine learning algorithm followed by your optimization algorithm. So likewise, we did the gradient boosting. So what I will do is how, with respect to what way, with respect to what parameter, how I am updating the way to reduce the error. That is very important. How the software metrics can be fixed for our data set. So I'm not getting it, but it depends on your data. Suppose, for example, if I take, so the one important metrics, we will find the autocorrelation. So if there is more correlation, directly we don't need any optimization problem or machine learning algorithm. We can solve it by simultaneous equation or quadratic equation or simple slope equation. We can fit into that fitting model we have. If it is uncorrelated data where we cannot find any mathematical difference, for highly non-linear data, we will go for machine learning algorithm. So likewise, these are metrics we can do. I think these are the questions, ma'am. I think I've answered whatever you have sent. So still, okay, if you are having any query, put it in the chat box. Through them, I'll try to answer. So this is my personal mail ID. You can send your queries, or if you need any help, I'm ready to do it. So that's it. Thank you for your patience.
Okay, sir. So participants, if you have any more queries, you can just mail him. His mail ID is visible on the screen. You can just note it down. So thank you, sir, for giving an insight to the application of artificial intelligence, that is machine learning. And first of all, I thank God Almighty for leading this session. I also thank our management, college management, principal, Dr. Ebidarne, and our Assistant General Manager, Mr. Manimaran, our HOD, Mr. Relin Francis Raj, and Mr. Ashok Kumar, and also Mr. Emmanuel for making this webinar a grand success. Thank you, participants, and you can subscribe our college YouTube channel, SCAD Engineering College, to get notifications about the upcoming webinars. So you can also find the feedback link, which will be available in the YouTube chat box. You can find that. You can fill that, and you can get your e-certificate. There won't be no issues. I repeat, you can find the feedback link in the YouTube chat box. So that's all about today's session. I thank Shankar Ganesh sir for his valuable time. Thank you, sir. Thank you
Thank
so
you.
much. Okay. So thank you, participants. Have a good day.